What's up guys, this is Massey. Welcome to another video. In this video I want to show you some examples regarding solubility. First example, the solution contains 2 times 10 to the power of negative 3 molar of cerium and 1 times 10 to the power of negative 2 molar iodate. Will cerium iodate precipitate? And the Ksp of cerium iodate is 3.2 times 10 to the power of negative 10. So here we have cerium iodate in solid form. When it dissolves, it's gonna produce its ions in aqueous phase like that. Q will be concentration of cerium times iodate to the power of 3, because here the coefficient is 3. So as you see here, the concentration for cerium is 2 times 10 to the power of negative 3, and iodate is 1 times 10 to the power of negative 2 to the power of 3. That's going to make it as 2 times 10 to the power of negative 9. That's Q, and since Q is greater than Ksp, if you compare 2 times 10 to the power of negative 9 to 3.2 times 10 to the power of negative 10, see Q is greater. It means that it will form a precipitate. That's how we figure out. Next example. Calculate the final concentration of potassium ion and oxalate ion and barium ion and bromide ion in a solution prepared by adding 0.1 liter of 0.2 molar of potassium oxalate to 0.15 liter of 0.25 molar of barium bromide. For barium oxalate, Ksp is 2.3 times 10 to the power of negative 8. So first things first, we need to find out the number of moles of each of these solid. So we have 0.1 liter of 0.2 molar of potassium oxalate. So let's say 100 milliliter times 0.2 millimole per milliliter of potassium oxalate. That's going to give me 20 millimole of potassium oxalate. On the other hand, we have barium bromide, 150 times 0.25 millimole milliliter of barium bromide. That's gonna give me 37.5 millimole of barium bromide. Then we have barium reacts with oxalate to completion, and it's going to produce barium oxalate in solid form. So we have before change and after. Before we have 37.5 of this guy, and here we have 20. So negative 20 is going to be 0, and this one 17.5, and barium oxalate is going to be 20. So then the new initial concentration for barium is 17.5 millimole per 250 milliliter, because you mix them. That's going to be 7 times 10 to the power of negative 2 molar. Oxalate ion is going to be 0 because it's consumed. Potassium ion is also, it's going to produce 2 of them, so it's going to be 2 times 20 divided by 250, which is going to be 0.16 molar. And bromide is going to be 2 of, from here, 37.5 divided by 250. That's going to be 0.3 molar. So these are going to be all the concentration. So we have BaC2O4 gives Ba2 plus C2O4 2 minus. Ice table. We have 0.07 in here initially, 0 in here. Then when it reaches to the equilibrium, we have 0.07 plus x, and here we have 0 plus x, which is going to be x. So 0.07 plus x and x. That's supposed to be equal to KSP, which is 2.3 times 10 to the power of negative 8. So that's going to be 0.07 plus x times x. We neglect x in comparing to 0.07. Then it means that x times 0.07 equals to the KSP. So x will be 3.3 times 10 to the power of negative 7 mole per liter. That's the oxalate concentration. So in this example it says a solution is prepared by mixing 75 milliliter of 0.02 molar of barium chloride with 125 milliliter of 0.04 molar potassium sulfate. What are the concentration of barium and sulfate ions in this solution? So we have BaSO4 together. So we need to find out the barium ion concentration initially as after we just mix them. 125 plus 75 is going to be 200. So in the original solution it is 75 times 0.02, that's the concentration. That's going to give me 7.5 times 10 to the power of negative 3 molar. Sulfate ion initially is 125 divided by 200, and here the concentration is 0.04. That's going to give me 2.5 times 10 to the power of negative 2 molar. So Q will be barium times sulfate, which is 7.5 times 10 to the power of negative 3 times 2.5 times 10 to the power of negative 2, which is going to be 1.9 times 10 to the power of negative 4. That's greater than the KSP, because KSP is 1.5 times 10 to the power of negative 9. That's much greater. So it means that barium sulfate will precipitate. So BaSO4 gives Ba2 plus SO4 2 minus. Here we have 0.0075. Here we have 0.025. That's B4. When it reacts completely and goes to completion, we have negative 0.0075, negative 0.0075. So we're gonna end up having 0, and here we're gonna have 0.075. And then when it reaches the equilibrium, it's gonna have plus x and plus x in here. So KSP, which is 1.5 times 10 to the power of negative 9, equals to x times 0.0175 plus x. Then we neglect this x in comparing to this guy. X will be 8.6 times 10 to the power of negative 8 mole per liter. That's going to be the concentration of barium. 8.6 times 10 to the power of negative 8 molar. Concentration of sulfate we already found, 0.0175. So that's going to be the concentration of barium and sulfate ions in this solution. I hope you enjoyed this video. Please leave me a comment if you have any questions.